Okay, so last time we got through most of 7-6. Just a couple types of problems we didn't get to. But remember, pretty much everything boils down to getting it to a quadratic and factoring it. Or just factor, if you can just somehow do that. So if you look at all the problems that we've done and you go back in the notes, they pretty much all looked like that. Eventually, if you got everything on one side and you got it equal to 0, you had 3 terms. Something here raised to the second power, something here raised to the first power, but the same trig function, okay, once you use an identity, and then the last thing here was always a constant. So every problem that we've done had 3 terms in it, just like that. Even this one, it has 3 terms, you just gotta move everything to one side. How many terms does this one have? It has 4. Okay? You can't factor something with 4 terms the same way you can with 3. When you have 4 terms, you do factor by grouping. So I had to set this up very special to make it work. Factor by grouping means you take what you can out of the first 2. 1, 2. And then factor what you can out of the last 2. The 2 that are in red, what do they have in common? They have cosine. So we're just going to factor it out and see what happens. Cosine. If you factor it out of the first term, what does that leave you with?
2 cotangent.
2 cotangent. Copy down your minus. And what if you factor it out of the second term? 3. So the goal now is when you factor out what the green ones have in common, you get 2 cotangent minus 3 again. If you do, then we're good. If not, then you're in trouble. So what can you factor out of the ones in green? 3. If you factor a 3 out of the 6, what do you get? 2 cotangent x. And factor 3 out of 9? 3. So now we have 2 terms. That's a term. That's a term. Do the same thing again. What do those 2 things in blue have in common? 2 cotangent x minus 3. So we're going to put that in front. Okay? Just like in red, the cosines were in common, we put it in front. Put the 2 cotangent x minus 3 in front. Times. If you factor that out of the first blue one, what's left? Cosine x. If you factor it out of the second blue one, what's left? Great. Now you factored it. So now what do we do with each one of those factors? Yep, let's do the one on the right first. Cosine x, when we move the 3 to the other side, what will it equal? Negative 3. And to get rid of cosine, what would you have to do? Inverse cosine. What's going to happen when you try to type that in? Right, because that's beyond negative 1 to 1. The domain for inverse cosine is just negative 1 to 1. That's beyond it. No solution. Does that mean the whole problem is no solution? No. It just means that part didn't have a solution. Let's look at the other part. Okay. What would cotangent x equal? Plus 3 divided by 2. Now, if you had a button for it, what would you want to do on both sides? If you had a button for inverse cotangent, that's what you would want to do. There's no button for that. The only inverse you can do is inverse sine, inverse cosine, and inverse tangent. So we've got to think of this a little different. What other function is connected to cotangent? Tangent. So what's the connection between them?
They're inverse.
They're reciprocals. Someone said reciprocals. So if the cotangent is 3 over 2, then what does that mean the tangent would be?
2/3.
It's 2 over 3. Now we can solve. So now, what would you do on each side? Take the inverse tangent. So x equals inverse tangent, 2 over 3. Now before I type it in, let's just think of this. We're looking for where the tangent equals a positive number. Where is tangent positive? 1 and 3. Let's see what inverse tangent of 2/3 gives us. Okay. Second inverse tangent.
What are you in right now? What should you be in?
It didn't say degrees or radians. It just said find all solutions. So I'm going to do it in degrees. Plus, whenever you can factor, I said always use degrees first unless they tell you not to. So we get an answer of 33.69. What quadrant is that in? 1. There's that answer. It's always good when you get the quadrant 1 answer because it means you have your reference angle. We want quadrant 3. Add 180 to that. So that's 213.69. And if you want to check it, just plug that in, take the tangent of 213.69, and it should come out to 0.6 repeating. Close. Why didn't it come out exact? Because I round. But I could check the other answer as well. But since I based the second answer off the first one, the first one's probably right. Any questions on that? So, 2 things I wanted to show you here. One is if you ever see 4 terms, it's going to have to factor by grouping. That will always work. I wouldn't give you one with 4 terms where that couldn't happen because you don't have any other way to solve it. And 2, this little trick right here. We changed it from cotangent to tangent because we didn't have the right button to do it. You could do the same thing with secant or cosecant if that came up. Right. Last one. So this is specifically saying to find the answers in what units? It is saying radians. So we should do that. I'll probably do degrees first and then change it. Okay, what's different in this last problem from any problem we did 1 through 4? All right, there's only 2 things. What else? There's a coefficient in front of the x that's never happened. Even with 4 terms, the coefficient was always 1. Coefficient was 1. Coefficient was 1. Coefficient was always 1. It's a 2. Right? That's no good. So first thing we have to do is fix that. What can you change sine 2x to? 2 sine what? Times cosine x. That's from section 7.5. 2 sine cosine. From here, it's going to be super easy. But that, if you don't see that first step, then you're kind of stuck. Now, what do we usually get equations equal to when we're trying to factor them? So let's put everything on the left. How would you move the sign? Subtract it. 2 sine x cosine x minus sine x equals 0. Now, what could you do on the left now? Yep. Maybe you have 2 things in common, separated by addition or subtraction. Factor it out. Because if you can factor this, then we can set each factor equal to 0. If you factor sine out of the first term, what's left? 2 cosine. What if you factor sine out of the second term? 1. Easy. Then we have 2 factors. Set them each equal to 0 and then solve. All right, let's start with sine x. Now, I normally, if this wasn't 0, I would say take the inverse sine of both sides. But if you want to figure out where the graph of sine equals 0, I would just visualize that in your head. From 0, including 0, to 2 pi, not including 2 pi. So this is 0, this is 2 pi. Where does the graph of sine hit 0? 0, pi, what about 2 pi? Not including, so we don't write that. 0 and pi. So, x is 0, x is pi. Anytime sine is equal to 1, -1, or 0, that's how I always do it. If it's a number other than 1, -1, or 0, you're going to need inverse sine, and then the ASTC thing. Okay, so let's look at this one. What would cosine x equal? 1/2. Now, that's not a 1, a -1, or 0. It is a special number if you remember it, but if you don't, what could you do? Just take the inverse cosine. Anybody remember what inverse cosine of 1/2 is? 60. So that's your 60. So we get an angle of 60, which is what? Because they wanted radians? Pi over 3. Again, if you did that in radians, inverse cosine of 1/2, this number would have popped up on the screen. You're never going to remember that that's pi over 3. So do it in degrees first, and then convert it after. Okay, let's think of our chart. We're looking for where cosine equals what kind of number? Positive, which happens here and here. We have 60. That's here. So how do you get the answer in quadrant 4? 360 minus 60, which is how much? 300? I think we already did this maybe in the homework. 60 times what is 300? So just multiply pi over 3 times 5. And all of those answers are between 0 and 2 pi. It's easy to see that in degrees. 0, 180, 60, 300. Sometimes it's harder to tell when they're fractions with pi, but they are all between 0 and 2. Right. Any questions on this? The only thing new in this problem was using this identity. But then after that, I think that was actually easier than some of the other ones from yesterday. Quadratic formula ones are the hardest. All right. So we already did 1 through 10. So let's just do 11. Let's take out 12. 16 is quick. That's good for that. So for this part of the homework, those three, 11, 12, 16. Okay. So last thing we're going to look at, as I said, the easiest section for the week is section 8.1. This also starts the last chapter of straight trigonometry. Let's take a look at 8.1. Okay, so section 8.1 is on what we call the law of sines. Anybody heard of that or used that before?
I think we use it in
Might have done a little bit with it, geometry, or what you can do in algebra. Basically, what we're going to be looking at in this section is finding how long the sides of the triangle are and how big the angles are. Now you might think you've already done that. If I gave you a triangle like this, tell you this is 4, that's 20 degrees, you use SOHCAHTOA, opposite adjacent hypotenuse, and that's how you can solve it. Well, what we're going to be looking at when we solve triangles this time is none of the angles are 90. So if you don't have a 90, then what side don't you have in the triangle either? You don't have a hypotenuse. So opposite over hypotenuse, adjacent over hypotenuse, that doesn't do you any good. There is no hypotenuse. So there's two laws that you can use. Which law you use depends on what kind of information they start you off with to solve the triangle. One is called the law of sines. The other one is the law of cosines. So when a triangle doesn't have any 90s, it's called oblique. There's two main types of oblique triangles. All the angles are less than 90. We call that an acute triangle. A specific example would be an equilateral. That's an acute triangle. An obtuse triangle is where you have one angle larger than 90. Can you have two angles larger than 90? No, because they all have to add up to what?
180.
They all have to add up to 180. So, acute, obtuse. I draw every problem as obtuse. Nothing that I draw is really to scale. Okay. What's important is when you draw something, what you put across from what when you set your diagram up. What letters did we always use for the three sides? We're still going to use A, B, C. Then we had a name for the angle across from side A. Alpha, across from side B. Beta. And we didn't have a name for the one across from side C because it was always the 90. So we just called it the right angle. Well, now we're going to call it this symbol, which is gamma. G-A-M-M-A. Gamma. And it doesn't matter how you want to draw your triangle. And if you want to draw it like that, that's fine too. Just wherever you put A, put alpha across. Wherever you put B, put beta across. Wherever you put C, put gamma across. So I told you that there's two laws, and which law you use depends on the information they start you off with. In order to use the law of sines, they have to start you off with one of these two cases. Do I have pictures? No. I'll draw you a picture of each one. Angle side angle could look like this. Bless you. Angle, side, angle. You know two angles, and you know the side that's between them. 6 is connecting the two angles. Versus side angle angle, a little bit different. You know a side, an angle, and an angle. Yes, it's the same information. It's two angles and a side, but the location of the side is different. Here, the side is between the angles. It connects them. Here, the side is not between them. If you knew this bottom side, that I just put the red dot on, that would be angle side angle. So, any questions between the difference of the two types? So pretty much, if you ever have two angles and a side to start with, no matter which way they give it to you, you use law of sines. The other case is two sides and an angle. Specifically, it has to be angle, not between the sides. So, side, side, angle. So you've got a side, and they gave you an angle that's not between the two sides. If they give you this angle right here, the one between the two sides, that would be SAS. You can't do that with the law of sines. That's the law of cosines. So those are the only three types of problems that we can solve with this law. That's what I just told you. Okay, it doesn't really matter the order you write. Like if you write SAA or AAS, some people reverse that. That's the same. ASA, some people even reverse that one. And they go with ASA. This one, if you reverse, I'm not going to write that. So if you reverse it, that's not nice. So we'll leave that one as side-side angle. Okay. So let's take a look at the law of sines. A very easy formula to come up with, like where it comes from. So start with a triangle with none of the sides the same. That's supposed to look pretty scaly. And what I'm going to do is just draw in that as my height. Don't confuse h with hypotenuse. That's the height. Maybe not the best letter. Okay, I'm going to label two of these sides. I'm not going to need the third side. Let's call this side A, this side alpha, this side B, this side beta. If I take the height out, you can see why I did that. A across from alpha, B across from beta. I don't need C or gamma in this block. Okay, any questions on that? So what I want to do is look at it as two separate triangles. I'm going to block the triangle on the right first. Let's go like this. Now, what I want to do is come up with a formula for h. So when I'm done, I want a formula in that box. I have that angle, that side, and that side. What's the name of the side that's labeled h from the perspective of beta? It's opposite. H is opposite the angle. What about A?
Hypotenuse.
Hypotenuse. Opposite hypotenuse. What trig function from Sakatoa has those two? Sine. So the sine of your angle equals opposite over hypotenuse. Now, how would you get h by itself?
Multiply by A.
Multiply by A times A, and you get h equals A sine beta. So there's a formula to find the height of that triangle as long as you know A and beta. Okay, any questions on that? And I'm going to call that box 1. Now, I'm going to block the other triangle, and I'm going to do the same thing. I want to find a formula for the height again. But this time, I want to use what you can see there. Angle, got a side there and a side there. What are the two sides that I have this time? And what's h? It's opposite. And what's b? Hypotenuse. So it's sine again. What would the sine of alpha equal? H over b. So, what would h equal?
B sine.
B sine alpha. Good. Let's call that box 2. Now, what do you know about box 1 and box 2?
They're equal.
Right. Box 1 equals box 2 because they both are equal to the height. It's like the transitive property. So box 1 equals box 2. Let's write that down. A sine beta. No, I'm going to write it like this. A sine beta equals B sine alpha. Box 1 equals box 2 equals box 1. Same. I just want to write it that way. Any questions on that? Now, what I want to do is put the B over with the beta and put the A over with the alpha. So to do that, what could I divide both sides by?
AB.
AB. Divide by AB. Divide by AB. B's are gone. A's are gone. Now, we're left with this. Sine of alpha over A equals sine beta over B. And that's pretty much the law of sines, the first two parts. We didn't prove this third part, but based on the pattern, do you think you know what the third fraction would be? Sine of gamma over C. Yeah. So that is the law of sines. Sine of alpha over A equals sine beta over B, which we proved. Went through it. And the third part we just kind of assumed from looking at the pattern from the first two. So each fraction there, you never use all three at the same time. You either use the first two, the last two, or the first one and the last one in the problem. But what you're going to be setting up is a lot of these. What are those called when you have a fraction equal a fraction? Yep, a proportion. And how do you solve a proportion? Cross multiply. So we're going to be setting up proportions where three of these are going to be numbers, one of them will be a letter, and you're going to cross multiply, and that's pretty much how every law of sines problem works. Remember, you can still use this fact. Even though the triangles are not right triangles, all the angles still add up to 180. Don't use Pythagorean theorem. That doesn't work anymore. Because the Pythagorean theorem is only if you have a right angle. Okay? So the rest is just examples, and we'll see how many we get to. I have 3 examples, one of each type. Okay. So first thing that I do to help myself is I organize everything like this. 3 sides, 3 angles. Right. Do we know A? Yes. Do we know B? Let's put a box so we remember to find it. Do we know C? Do we know alpha? Yes. Do we know beta? Do we have gamma? Not yet. Now, when we solved right triangles, what did I say about using something that you calculated to find something else? Yeah, don't do it. Because if you found it and it's wrong, then other things are wrong. Well, here, sometimes you can do that a little bit, but sometimes you can't. You are going to have to use gamma to find C. There's no way around it. So that means if you get gamma wrong, C is automatically going to be wrong too. But if you get gamma wrong, you could still get B right, because B has nothing to do with gamma. Each row only affects basically itself. Okay? So gamma has nothing to do with finding B. Beta has to do with finding B. So we're going to set up a proportion. And to do it, you have to pick 2 out of 3 of the rows. You always want to pick the row that has everything in it. That's like your starting point. So let's start with row 1. A is 4, alpha is 20, and fill that in right here. A is 4, alpha is 20. So we've got sine of alpha over A equals, and now from here it depends on what we want to do. We could go ahead and find B right now, or we could get gamma out of the way and get that. Depends. Let's just do B first, just to show you don't need gamma at all. And I know you could figure it out easily, but let's do gamma after. So let's find B. Sine of 20 over 4 equals, what's going to go on the other side? Sine 60 over B. Okay. Cross multiply. 4 sine 60 equals B sine 20. And now what would you do to get B by itself? Divide by sine 20. Notice we're not finding any decimals. We don't care about the decimal till the last step. So just divide by sine 20. It's a number. It's some number. We don't know what it is. It doesn't matter what it is. I don't care about the sine of 20 at all. I care about 4 sine 60 divided by the sine 20. Now I'm going to type that. Okay, I think every problem in this section is degrees, so let's make sure we're in degrees. And 4 sine 60 over sine 20. It's important you close that parenthesis. And we get about 10.128. So if they don't say, we're going to go to 3. 10.128. So I did that first, not because it was the easiest one, but I wanted to show you I could do it without finding gamma at all. Now to get C, I have to get gamma first. Because if a row is completely empty, it's useless. You can't use it. You've got to know something in the row to make some progress. So we've got to find gamma first. What's gamma? 100. Very important we get that right because 2 answers depend on it. Gamma and C. So now we're going to find C. So, to find C, you have a couple options. I said to use a row with everything in it. Row 1 and row 2 are full. So which row should I use? 1. Yeah. I'd use 1 just because it was given. The numbers are nicer. So if you made a mistake with B, it's not going to mess up C. So sine 20 over 4. And what's going to go on the other side? Sine 100 over C. Now, you can show me the cross multiplying out, or if you can do it in your head, that's how I usually do it. It's 4 sine 20. 4 sine 100 divided by sine 20. So 4 times sine 100 divided by sine 20. Any question on how I got that? It's the same thing I did here. I just did it all in one step. Cross multiplied and divided by what would have been next to C. All right. Now before I type it in, we know that C should be the biggest side, but it can't be bigger than 14.128 because any 2 sides added together have to be bigger than the third. So it's between 10 and 14. So let's see what it comes out to. 4 sine 100. Close the parenthesis, that's important. Is closing it here important? No, because it's at the end, nothing else is coming after it. 11 point, what is that properly rounded? 518. And that's a law of science problem where you have 2 angles and a side to start with. Now, I didn't even check that this was a law of science problem. And this week on the test, you're not going to have to because we're not learning law of cosines. Once you know both laws, you should check which law it is. And the way you check it is you draw it. A, alpha, B, beta, C, gamma. Angle, angle, side. So I would go back to my notes. I would look up AAS or SAA, same thing, but AAS is a law of sine problem. Right? So that's the first thing you should check, but I'm not going to today because everything's law of sines. All right, let's try this one. Actually, this one's easy to check because the diagram's right there. What kind of triangle is it? What is it with the 3 letters? ASA. If you look back in the notes, ASA is law of sines. Right. Set up our sides. Set up our angles. Do we know A? Do we know B? Do we know C?
Yeah.
Do we know alpha?
45.
Yes, it has to be across from A. Do we know beta?
40.
40. This time, let's find the angle right away.
80.
So these add up to 85. So gamma would be 95. Now, gamma is very important you get right because that's the only row with everything in it. If you get gamma wrong in this one, what's going to happen?
Everything.
Everything. Yep. So if gamma is wrong, this time it's all wrong. There's no partial credit at all. All right, so let's start with A. Anyone think they can give me the proportion to find A?
Sine of 94.
Yeah, Vinny?
Over 4.
Mhm.
Divided by the sine of 40.
Equals, yeah.
Equals sine 25.
Over?
A.
A. Yep, let's set B up at the same time. Find B. What's going to go on the left? Right. And I'm doing this to point out the fact that you don't need A to find B. I'm setting up the formula for B right now without knowing A. I'm not going to use A at all. Sine 95 over A equals sine 40 over B. And when you cross multiply, A is going to be what times what divided by what? 4 sine 45 over sine 95. Okay, so that will give me A sine, I think that was supposed to be a 4, I'm sorry. That looked bad. And what about B? Yep, 4 sine 40 over sine 95. Okay. Now we just type each one of those in and see what we got. So 4 sine 45. Close it or it doesn't matter? Close it. Don't close it like that. Divided by sine 95. So A is 2839. And B, pretty much the same calculation, so I'm just going to bring up the last thing I typed in and change 4 sine 45 to 4 sine 40. 2.581. Okay, let's check biggest side with the biggest angle, smallest with the smallest. Looks good. Any questions on that type? Okay, so only difference between this type and the last type is that if you get the angle wrong, it's all wrong. In the other type, if you get the angle wrong, it only would mess up one other thing, not everything. All right, so last type. Let's, I do want to make a sketch of this one quick. Just to see the type. So I'm going to do A, alpha. Let's do B, beta. C, gamma. What type is this? Right. You know a side, and you know an angle. But the angle is not between the two sides. That would be gamma. So, it's side-side angle. And I shouldn't really even have to tell you the next thing. You could kind of figure out what's probably going to happen here. But we'll look at it and see why. You could end up with one solution, two solutions, or no solutions. Because something's going to come up here that didn't come up in the last two. But something we've been doing pretty much all week. Okay, this only comes up with side-side angle. You never have to worry about what I'm showing you right now with any of the other cases we did yesterday, or any of the other cases we're going to learn when we do law of cosines. This is a unique thing to SSA. And the way I remember it is if you spell SSA backwards, that's why this case can be a pain in the... There you go. Right. Because of the 1, the 2, or the none. So here's your table. Now, even if you didn't draw the diagram, you can tell by the table that it's SSA. The way you can tell is you have a completely empty row, and you have no way to find anything in that row until you find something else first. And you have a completely full row. This has happened in every problem. Full row to start, full row to start. Always had a full row to start. If you ever don't have a full row to start, then just forget about law of sines altogether. That's law of cosines. Like think about if you knew side, side, side. You wouldn't have a full row. And so this whole thing we're learning today wouldn't work. But the fact that there's a full row and an empty row tells me that this is the worst possible type of problem. So you have to find things in a certain order. There's no options. What do you think you have to find first? You have to find beta. So I'll just put a 1. And then what do you think you can get after you know beta? Then you can get gamma, because you'll have 2 out of 3 angles. And then the third thing is C. Okay, so let's set it up to find beta. So Derek, what's going to be my proportion to find beta?
You knew. So is it 3 sine 43 or okay. Sine of 40 over 3
Sine 40 over 3, yep.
equals sine of beta over 2.
Good. Before we go any further, what's different about that? Something different here.
There's been no sign of beta yet.
We've always known the angle. This time we don't know the angle. So when we're done, we're going to have to get rid of sine somehow to find that angle. And whenever you're getting rid of sine, that can result in 2 answers, which we already know how to find the 2 answers. We have to get it to that point. So start with cross multiplying. 2 sine 40 is going to equal what? 3 sine beta. So I'm going to go like this. It would be 3 sine beta, but I'll divide by 3. And now I want beta. So what do I have to do on each side? Yeah, take the inverse sine. And this is the step that you always have to do anytime you have side-side angle. You're going to have to do inverse sine. And an inverse sine here. Okay. So let's type that in and see what happens. If this number is bigger than what, we won't be able to do it.
1.
What about if it's smaller than -1? That's how you could get no solution. If this number comes out between 1 and -1, then that's when we could get the 2 solution or 1 solution. Depends. So 2 sine 40 divided by 3. Inverse sine. 2 sine 40 divided by 3. So this problem, unless you type something in wrong, it's not no solution. That's a solution right there. 25.374. So let's put that down right there. I wrote it higher in the box because if there's a second answer, I'll put it below it, and I'll call it beta 1, beta 2. Now, when you're solving for your solutions, it's all or nothing. You're either going to get 1 answer, 1 answer, 1 answer. 2 answers, 2 answers, 2 answers, or no answer, no answer, no answer. They all have to be the same type. Right? So they're all 2, they're all 1, or they're all none. So, we're looking for where sine equals a positive number. 2 times the sine of 40 divided by 3. That was a positive number. What other quadrant is sine positive? 2. So what do you do with your angle to get an answer in quadrant 2?
189.
Subtract it from 180. 180 minus 25.374. So if there's a second answer, that's what it would be. 154,626. You now have to kind of reason out whether that answer works.
No,
Why?
it would equal 190.
You were given a 40 to start. You're saying that could be the second answer. That would add up to 194. If that had come out smaller, maybe like 110, then I would say yes, it would have worked. But the biggest the second answer could have been is how much? And have it still fit in the triangle.
139.
Yeah, like 139.9 repeating. It had to be less than 140. It came out bigger than 140, so it doesn't work. So first of all, any question on how we got the 154? Okay, any question on how we know it doesn't work so we can cross it out? Right. Because it doesn't work, there's only one answer for gamma, one answer for C. So, how can we get gamma now? What are those at? What did the first two add up to?
65.374.
So 180 minus 65.374. So now we've got gamma, and now the last row isn't empty. We've got something in it. Which means now we can finally figure out C. So let's find C. So to find C, which row do you definitely want to use? Row A, B, or C? You have to use row A. Well, I mean, you could use row B, but it's not a good idea. How come? Yeah, you weren't given beta. I mean, we're going to have to use row C, and we weren't given that either. But at least if we can use less stuff that we're unsure about, that's good. So let's use the stuff we know. Sine 40 over 3. And what's going to go on the other side to find C? Sine 114,626 over C. So sine 114,626 over C. Right, so C is going to be 3 sine 114 divided by sine 40. 3 sine 114, 626, divided by sine 40. All right, so before I hit enter, what do I know about C? It's got to be less than 5 and more than 3. So that really narrows it down. It's somewhere between 3 and 5. If you get a number that's beyond that, double check. 4.243. Perfect. Now, if I had time on the test, could I check it with Pythagorean theorem to see that C is right? Why? Yes. That's not a 9. So if you check it with Pythagorean theorem, that's not going to work. Yes. It always has to be, any two sides added together have to be bigger than the third, but it was the biggest angle, so it had to be bigger than the third. Yep. Okay. So any questions on that? So I think I wrote down everything that we did. You guys, this is more for like my intro to trig when they don't know how to do the second answer, but you guys already know how to do it. Take the answer you got and subtract it from 180. You always subtract it from 180. It wouldn't make sense to find an answer in quadrant 3 or 4 because those angles are bigger than 180. You can't have an angle that big in a triangle. So the second answer has to be in quadrant 2. Once you find it, the extra step today is to check and see if it fits with the given. So this is what we did. We found the second answer. It was 25 point something, 25.4. We subtracted it from 180, and we got this. But the angle that we were given was 40. You can't fit 40 and 154 in the same problem, same triangle. Okay? It's greater than 180. Right? So this time the other answer was too big. Any questions on that? So on a test, you probably wouldn't have more than 3 of these, and it would count. This would count as 3 questions. So everything we did in class today, this one would have been 3. This one would have been 3. And that one would have been 3. So this would have been 9 questions on this. Because each question has 3 parts. And usually I set it up just like that. Okay? Short answer with the boxes, you have to fill in the boxes. All right, so the homework is the 7.6. I gave you those 3. What were those 3 questions?
11,
11, 12, 15.
So 7.6, and on page 435, it's 5 through 8, 10, 16, and they didn't have problems like this in the book. You don't have to do this one, just that. So we have finished everything for the week. So let me just write this down. So for tomorrow, if it's normal, we're going to have a review. If it's a delay, we're going to have a review. If it's no school, then we're not here. So that would be tomorrow. Friday, if it's normal, we have a test. If it's a delay, we're going to do a test. If there's no school, we're going to do a test. Okay, so no matter what, we'll have a test on Friday with reviews, possibly, if we have school. Okay.